All right, so let's talk about how we analyze discrimination with the bell curve, or really looking at the discrimination within the bell curve, because that's what we're going to be talking about. So the bell curve is a graph of the normal distribution curve, okay? The normal distribution curve is sort of like an adjusted version of some data. I'm going to talk about that in a little bit in just another slide. The point is the bell curve is shaped like a bell. That's how it gets its name. So the top part of the curve represents the average or the mean values of a set of data. The idea is that in a normalized curve, most of the data values fall close to the average. And then as the curve travels down and away from the mean, the values get further away from the average. So the bell curves are usually used in IQ tests, standardized testing. They're used to measure like height, weight, blood pressure, a lot of other natural and psychological data. Okay. Normalization or normalized curves, it basically just means to adjust the values measured on different scales to a common scale. So because like, if we're talking about like blood pressure and stuff like that, like each human is different. So technically they can all be measured on a different scale, but we want to make it common so that we can apply it to humans as a whole. So we know what like is considered a normal blood pressure versus what's considered a non-normal blood pressure. So for standardized tests, this means that even though there are students from different parts of the country with different backgrounds and experiences, they take like all of the scores and they adjust them. So if it's on one scale, and that basically allows them to figure out where everybody's test scores fall. So theoretically, this works, but humans and human error can cause a bunch of problems. So that's why normalized curves are not perfect. Um, so how we normalize normalized curves. First, a person's going to find a mean, okay? So we've already talked about how to find the average, how to find the mean. You add up all of the data points, you divide by the number of data points there are. Pretty simple, right? Then you just draw a bell curve. It looks like this. Group, okay? The top, this mean right here, right down the middle, that's where you would put the mean because that's in the center, and that represents the topmost part of the peak. Then you're going to go ahead and label the bottom and the sides of your distribution. You're then going to find the standard deviation of the data set. So this represents an interval of data values away from the center. So if your mean is in the center, a standard deviation is to the right or to the left of that mean, okay? You want to do the +1 and the -1 because that's like within one standard deviation. And then you have the second standard deviation and the third as well, okay? I'm going to talk about how to find the standard deviation in just a second. So understand that within one standard deviation of the mean, 68% of data values will fall underneath that in a normalized bell curve. Okay, so 68% of the whole data set will fall in the red. All right, these are the values closest to the average. Now, any data values within two standard deviations of the mean represent 95% of all the data in the set. Okay, if you're looking to the right of the mean, that's all above average, and to the left of the mean is all below average. Okay, so now let's take it where we're looking at three standard deviations. So the red parts right here are just the little itty bit that's not included on either side. 99.7% of the data falls within three standard deviations of the mean, okay? Any values beyond that are part of an outlier group, okay? 0.3%, so 0.15% on each side, okay? Now, I want to talk about the why, okay, or like how they can discriminate. So because normalized curves are based on the average values of a data set, they can help or they can be problematic. They're good for helping us know like what's normal for a human in terms of health stats and being able to diagnose people who are sick. But then they also, when we're talking about like IQ tests or measures of human ability, they can basically lead to discriminations because like people are different and the test doesn't account for every person's differences and experiences. So to calculate standard deviation, you're basically going to find the mean of an average of the data set. And, we've already talked about how to find the mean or the mean average of the data set. Now we're going to calculate the standard deviation. So basically what you have to do is you click the link that I have here. It'll take you to this page. All you have to do is put the numbers of your data set into this box. Separate them by a comma. Now, if you're talking about a sample group, which is less than 200 people, you're going to click sample. If you're doing like a big group of like more than 200 values, which you probably won't, you're going to click population. And then you click calculate. And all it will do is do the calculation for you, and you just copy down the standard deviation. Okay? Super simple. There's a whole math process to it. As you can see, it's a little bit complicated. Not making you do it. Just use a calculator, and that'll give you the standard deviation. Okay? Um, so yeah, population is a data set over 200. Sample is something less than 200. So let's talk about a skew. In the center is our normal distribution curve with symmetrical distribution, which is the left side looks exactly like the right. Now, positive skew means it's leaning towards the left, okay? Notice how in a symmetrical distribution, the mean, median, mode are right on top of each other, whereas the mean is slightly to the right on a positive skew and slightly to the left on a negative skew, okay? The mean, median, and mode don't fall perfectly within line on a skewed curve. This mainly is just showing how distribution varies from a normal curve. That's really all it is. So looking at this, you can see that like here, you have the black population that's leaning to the positive side. Okay, it's leaning to the left. So this is a skew versus the normal of the white people IQ test scores. Okay, so in this particular case, IQ tests are typically normalized for white scores for white people. Okay, and they typically show a positive skew for the black scores, which is not a good thing, right? Where the mean IQ scores for black people fall in the lower second standard deviation for white people. So that means that cultural and economic gaps often make it really difficult for black people to make the same average score that white people do. Okay, so that is it for my slides today. Ran through it a little bit fast. If you need support on this, please, please, please reach out during my live sessions or office hours. You can also schedule an appointment with me if you need additional help. You're going to go ahead and do a couple little activities left over for the rest of the week, and then I will see you next week for the next set of notes. Take care, y'all. Bye.